Dr. Mueller is in Mexico City right now, so she asked me to introduce our speaker, who I'm delighted to introduce because I know him and I know his work, and he's part of the School of Architecture family, if you haven't met him before or heard of him. But Dr. Steve Windhager is on the science faculty of the Lady Bird Johnson Wildflower Center, and he also teaches in the School of Architecture in the Landscape Architecture program. And he has done a number of interesting projects, all very applied, but as a scientist, he's also involved in research. And now that the Lady Bird Johnson Wildflower Center is part and parcel of UT, reporting and collaborating directly with the College of Natural Sciences and the School of Architecture, he's a resource that once you hear what he's doing on this project, you'll certainly want to call him up, buy him coffee, and collaborate with him on some things of your own personal interest. The program he's going to talk about today, I'm not going to describe because that's what his talk is all about. But it's a very exciting opportunity as students and faculty here to be a part of this and to monitor its progress. So I'm just encouraging you not just to listen passively today, but to make note, to meet with him later and find ways to collaborate with him and his staff at the Lady Bird Johnson Wildflower Center. So Steve, thank you so much for coming.
Thanks, Kevin.
And we look forward to your talk.
Thank you. And just so you guys know, I'm very informal, so at any point in time, either interrupt me or raise your hand or anything else if you want me to cover something in greater detail. I am going to apologize in advance that I'm going to probably run out of here shortly after 1 o'clock. We're doing prescribed fires at the Wildflower Center, and I'm supposed to be the burn boss, and it's probably a good idea if I'm there before the fire starts. Thank you for having me today, and I'll get right into it. What I'm going to talk about today is the Sustainable Sites Initiative, and I should probably back up and give credit to our partners that are working on this. In addition to having representation from the Center for Sustainable Design here at the university, we also, the three main partners are the American Society of Landscape Architects, the Wildflower Center, and the U.S. Botanic Garden. And then we have working with technical experts from across the U.S., including folks like the U.S. Green Building Council, have representation from the Nature Conservancy, from the county health organizations. We've got all sorts of folks participating in helping us create a really good standard. And what we're trying to do is create the equivalent of green building for landscapes, for lack of a better word. Because the truth is, green buildings are still not, we're not done with those yet. Unfortunately, too often our cultures assume that if it's green, and it has green grass on it or something like that, that it's sustainable. But oftentimes we have tremendous resource use that's being taken up by those landscapes, and they really are not managed and operated in a way that can be considered sustainable in any way, shape, or form. What do we mean by sustainability? For starters, most of you are going to be familiar with this. I hope you're already familiar with this coming out of this community regional planning program. But if not, there are sort of three legs to the sustainability stool, if you will. There's sustainable, economic sustainability, which of course means that we have profitable, competitive businesses that are able to continue to be profitable and competitive into the future. We have healthy communities, which of course means that the individuals that are in those communities are able to make a living that they can continue into the future and perhaps pass on to future generations. We also have sustainable environment, and that of course means that you can continue pulling things, getting the services and the benefits of the environment you live in without compromising the future. So of course that all gets summed up in the Brundtland Report definition that came out way back in 1987. They defined sustainable development as the ability to meet the needs of the present without compromising the needs of the ability for the future to meet their own needs. And that's still really what's guiding us. When we talk about, I'm going to focus on the environment piece today. And sustainable sites really deals with that part of the circle, but of course it overlaps very closely with the economics and the healthy community. So we can't talk about the whole thing without, we can't talk about just the environment alone. So we'll be talking about the environment, but we'll also bring in terms of economic valuation. We'll talk about the benefits to human health and all sorts of other things. So when we talk about sustainable natural environment, what we mean is really the production of ecosystem services. How many of y'all are familiar with that term? Not a whole lot, but okay. So what ecosystem services are, and there's a great article that came out in 1997 by Robert Costanza, that came out in Nature, where he and a long group of folks value the things that the environment does for free, and they call them, and this is not a term he coined, but Gretchen Daly, Costanza, a number of other folks have pulled together a term called ecosystem services. What it is, these are the products and services that nature gives us for free, that if it didn't give these to us, we have to pay for it, right? So this is clean air, clean water, all sorts of things. We're going to run through it. Later, authors have divided this up into sort of 5 areas, and I'm going to run through and give you some examples of what those are. So provisioning, apparently I skipped regulating services, so I did it in the same order. Regulating services are things like climate. This is regulating global greenhouse gases and keeping our climate within a range of tolerance for us. This is what the environment does, again, for free. It's been creating oxygen and pulling in sequestering carbon dioxide for literally millennia, eons, really. It also cycles waste, so it takes the waste products that are created, cycles them through, and creates new products out of them. And this is a natural process that goes on out there for free, and that if we don't have the environment to do it, we have to pay for it. Also, nutrient cycling, that if you don't, that again, through taking waste and decomposing it, you end up keeping the nutrients available to plants and animals over time. And that if we don't have that cycle going on, you tend to have leaching where those nutrients go down and further into the earth where they're unavailable to plants and animals. Supporting services like clean air and clean water supply. A great example of this is New York, probably back in the early 90s, late 80s, was examining whether they had been told by US EPA that they needed to put in a new drinking water plant. Because with the projected development that was going to be happening up in the Adirondacks where their water supply came from, the water supply was anticipated to be degraded, and they were going to have to put in a drinking water plant to clean it before they got shipped out to the consuming public. Instead of building that plant, they also did a cost-benefit analysis of just buying the land outright to keep development from happening in that zone. They found out that they could avoid building a $6 billion water treatment plant by buying around $200 million worth of land. And by doing that, they're letting the landscape provide that clean water rather than forcing themselves to pay to clean it. But that's a great example of where the natural system is providing it for free. They're giving you the extra benefit of whatever, 200 million minus, 600 billion minus 200 million. That $5.8 billion worth of value is what's being provided by that ecosystem. That if it didn't provide it, they would have to. Of course, I'll just touch briefly, agriculture is another big one. There's huge agricultural values to ecosystem services, not just the growing of the plants, but things like pollinators. And what we've seen is that as pollinator populations have decreased across the U.S., now there's a business that's been springing up where they actually take bees that have their hives on trucks, and they move to different places where they need to have pollination going. And now services that they're moving these bees around to provide those ecosystem services because the native pollinators and the pollinators that are in that area have been exterminated over time. They're no longer there. Pest control is another one. Natural systems oftentimes have checks and balances against pest problems, and that usually by when the systems get out of whack is when you start having real problems with pest populations. Preserving services like genetic diversity. These are things where you can look at this as just insurance policies. The idea that in the rainforest there might be a cure for cancer. It might also have the next sustainable resource, whether it be for food or fiber production or anything like that. There are resources out there that we want to preserve into the future to make sure that we can adapt to change and that we can meet our needs in the future, even if we don't value those things right now. Additionally, it provides a physical component in that it creates a physical structural habitat and ecosystem value there. Cultural services. Of course, there's a lot of economic valuation that goes into that. Everything from property values and ecotourism. There's some great examples of this where most of, say, South Africa and Kenya's economy now is devoted to, and Costa Rica is doing this now too, has become devoted to ecosystem services and ecotourism. That the sustainable use of their natural environments is what their economies are primarily based You also can get examples where inner city London had a great example. The National Wildflower Centre over in Liverpool, England, our sister organization over there, installed a about 20-acre wildflower meadow in downtown Liverpool in an area that was a pretty depressed part of town. An area that before this had been primarily sort of hardscape area. They installed this wildflower meadow, and all of a sudden people got out of the tents that were around there and started walking this meadow and enjoying it. And there was actually a recordable difference in health concerns in the local medical shops because people were being more active just by the fact that they put this system in. That's a value that's less tangible, but also it helped property values in that area. Now, the tenant values went up by having this 20 acres of open space rather than 20 acres of just hardscape. And of course, it also helps our physical and mental stages. We won't go into too much of that, but if you're familiar with the Last Child in the Woods and some of the other nature deficit disorder things, we're learning all sorts of things about human well-being and how connected we are to the natural environment and how critical that is for us to develop in a functional way. All of this has led to the success of green building. And of course, green building started primarily out of a desire for greater efficiency and less resource use and waste. And they've done a great job. In the 10 years that the U.S. Green Building Council's been around, just using that as an example, they've grown tremendously. EPC now affects 10% of the overall construction industry, and that's a big industry. That's $10 trillion a year total construction industry. And they've seen tenfold growth over the last 10 years. In particular, this isn't, I often wonder how important this statistic is, but there's been over 45,000 LEED accredited professionals that have popped up. Now, of course, there's some sense of, that doesn't mean they're all getting employed, but we're seeing more and more and greater interest in being able to say and being able to market yourself as someone that knows something about sustainability. So, you guys should know this. This is the quiz I always give my students. Okay, is it A, B, or C? Buildings? C. Yes, that's correct. Buildings are in fact correct. You passed the quiz. This is, of course, from the Architecture 2030 website, Ed Nazaria's thing. He pointed out that he started looking into things and said, wow, buildings are the primary consumer of energy in the U.S. It's not transportation, it's not industry, it is buildings. And that's really one of the reasons that U.S. Green Building Council's approach to making buildings more efficient has been a critical step in sustainability. But that's not all. Water is a critical thing. How many of you think about energy when you think about water? Wow, you people are really progressive. Of course, it takes a lot of energy to not only clean, but also to ship and pump water around, both clean drinking water and wastewater. In Austin, about 50% of the total municipal load of electricity in Austin goes to treating and pumping and moving water and wastewater. 50% of our total energy in Austin, according to Austin Energy. And that's normal for across the U.S. Most municipalities spend somewhere between 25 and 50% of their total energy budget on clean water and cleaning water after it's been used. And of course, we flush our toilets with it. So it's been critical that we start seeing increased energy efficiency, increased water efficiency, and other things in these buildings that are LEED buildings. So here's 3 examples, 2 platinum buildings and a gold building. And here's the next quiz. What's missing? Yeah, there's no green associated with these green buildings. I mean, okay, you got the tree in the foreground here, but it's not even part of that building. The truth is, what has been considered, but not to the way that it needs to be, is the landscape component and how landscape not only help us in conserving resources, but truly what the opportunity is that when you look at the entire site, you have the opportunity to truly do something positive. Not just use less resources, but you can actually start doing things like carbon sequestration, filtering water, cleaning water. When we start thinking about living building challenge, there is no way to achieve the goals of the living building challenge without integrating the entire site. And just to give you an example, Berlin's pretty far ahead of us, and you guys in regional planning will be really interested in this. If you're not familiar with the biotope area factor, you need to go do some research. Seattle just adopted a similar approach. They call it green printing or something like that. But the idea is that Berlin came up with this a ratio of how much green space to hardscape, in a sense. It's a simplistic model for it, but just as a short, brief overview, it's kind of, they're giving credit for green walls, green buildings, all sorts of things, but they recognize that even in urban environments, we want to have this green infrastructure to help us achieve other goals. So they put as a minimum for some of their areas, they want to have a 0.35 rating scale for on this biotope area factor. Seattle, when they were considering adopting the same thing, looked at all of their LEED or better certified, silver LEED or better certified buildings that had been built in Seattle. And they weren't very happy with what turned out. Some of the best ranked green buildings actually have very little in the way of landscape sustainability components to it. So we need to be able to do better than that. And in fact, this is clearly not going to be good enough, because again, we can be as energy efficient as we want to be, but we're at a point now in our culture that we have to start rolling back the clock. We have to start actually sequestering more carbon than we admit because of where we are now. We have to start cleaning the water because we're losing these ecosystem services greatly. Projections on population increase in the next 60 years are going to be pretty drastic. At the very least, the numbers I've seen are suggesting that even with urban infill and urban redevelopment projects, we're looking at something like 65% of the future development between now and 2050 is going to happen in greenfields. Okay, is that an accurate number? You heard that?
I haven't heard of it.
Okay, I just made it up on purpose. That was a study by ULI that they're estimating that 65% of the future development is going to happen in green space, even with all of the steps we might put in place to really enhance that denser urban environment. So, given that that's the case, given that we're going to have greenfield development, we can't just make these buildings energy efficient. What we've got to get to is a situation where a truly sustainable landscape provides as much ecosystem services after development as it did before. And preferably, it provides more, at least of certain ecosystem services. Maybe that's clean air, clean water. It's going to depend on where you are. So, briefly again, this is going off the ULI study. They've identified some critical issues that they think are going to be the things that we've got to address in the next 20 to 30 years, or we're going to meet with all sorts of catastrophes. Of course, climate change, we've already discussed briefly that you can see that how environments can help us sequester carbon, but also we're starting to lose things like Joshua Tree National Forest is predicted to no longer exist in Joshua Tree National Forest. There will be no Joshua trees. Because as climate change, just a 3-degree shift in temperature change is going to make it too hot for these trees to exist where they are. And unless we plant them in other places, they don't have the ability to move fast enough to go uphill rapidly enough. Assuming we can transplant them, there still will be no more Joshua trees in the Joshua Tree National Forest, just as a result of that. And of course, we're also looking at climate change having all sorts of effects on coastal regions, where water levels are going to increase and flood greater areas. We have all sorts of predicted changes that are going to happen as climate change continues to occur. Habitat losses, habitat losses is another obvious one, in that as we continue to fragment a landscape where we have breaks in these sorts of ecosystem services, whether it be pollinators, whether it be cleaning water or anything else, these services become more and more difficult to provide. And we're going to have to start spending more and more money to do it. And that is, unless we decide that we can find ways to develop and have these ecosystem services as well. Water availability is another critical one. ULI is predicting that 36 out of the 50 states in the U.S. are going to have shortages that are equivalent to what Georgia went through this past year in the next 5 years. 36 states. And of course, water's been an issue in Texas since before many of us got here, of course. And so it was identified even by George Bush's Council on the Environment back in 2000, when he was governor, identified water as the critical resource for Texas in the next 20 years. That this is going to be what determines Texas' continued potential to grow, is more efficient and more intelligent use of the water. And of course, we already mentioned the human well-being. So of course, you know, they've linked the fact that kids don't get outside and be able to just play to attention deficit disorder, to just a lack of ability to concentrate, to all sorts of health issues from leading a sedentary lifestyle. But also there's things like when you have a view of green space from a hospital room, you recover faster. These are documented studies. That, as I mentioned before, when you get people that have an opportunity to go walk, whether it be around a town lake or some sort of other green space, they walk more, and all of a sudden, because they're walking more, they're healthier. So there's a lot of ties to our human well-being from improvement in the environmental system. So all this is increasing the value of the landscape and the site in a way that's oftentimes been too overlooked. So let's get right into this. What does it mean by this? So let me give you some economic numbers on, we'll talk sort of in generalities now, some economics on how important landscapes can be. In Minneapolis, they tried to total up the value of their street trees and what they were providing. And they found $6.8 million annual costs in energy savings, $9.1 million in stormwater reduction. The $7.1 million is a result of street trees. California showed for every dollar they invested, they got $1.89 back in terms of cost savings. So that's a really good argument for why trees are pretty valuable in these environments. And of course, you can cut energy production, so you can save on energy by strategically locating these trees. Again, a similar street tree study in New York, the foresters have gone very far ahead in looking at the value of the trees in the urban environment. They found all sorts of values. Again, a value of $47 per tree for every tree they planted. And certainly with some of the larger programs, you can see definitely a huge cost return on investment from that sort of thing. We talked briefly about ecotourism, but it is huge. Costa Rica has now shifted much of their economy over to that, with the focus that if they can have sustainable yields in terms of timber, but also really focus on generating ecotourism, they found that everyone that every person that's going to look at some of their habitat that they preserve is spending on average $1,500 US per person. And they look at that as the most profitable part of the tourism industry, because it's about double what the folks are spending that are coming on just to go lay on the beach. South Africa is a great example. When they started focusing on ecotourism, which was way back in the 1970s, and they actually switched over their economy from one of extraction to one of sort of value-added services. The African elephant was almost extinct and extirpated from South Africa before they started this. Now the population's on a rebound, which of course brings up other problems. They're having to start calling the herds again now. But they actually have been able to save significant portions of their environment and generate significant wealth as a result of it. And particularly, it's the local communities that are benefiting, because they really did a good job. Initially, they used the American model, and they built these national parks and kicked all the indigenous cultures out of them. And but since then, they've really been working very hard since the late 70s, when they found out that if they kick everybody out and don't give them a livelihood, what ends up happening is, of course, that you get poaching and you get problems. What they've done is they've really worked with the local communities around these parks to give them economic opportunity to be tour guides, to be paid guards, to keep poaching from happening, and to find other ways to generate revenue and income from this. And now they're very supportive of these parks, and the parks are thriving, and the communities are thriving. So what we're trying to do, again, with the Sustainable Sites Initiative, is work on creating a metric whereby we can evaluate the way that we interact with the landscape, everything outside the skin of the building. And we can actually provide credits in the same way you get LEED credits for a green building, provide those credits for the landscape. And I know that there is a Sustainable Sites portion of the U.S. Green Building Council's LEED program, but they're partnering this, part of the reason they're partnering is that they recognize how weak it currently is. We can do a lot better. So the fun thing about this is that there will be a lot of sites that currently can't get LEED certified that are opened up with this process. When you look at sustainable sites, it could apply to a park. It could apply to a campground or an industrial office park that currently isn't covered by LEED. Well, the buildings might be, the entire park itself couldn't be. Certainly botanic gardens we're very excited about, because up until now there have been a number of botanic gardens that have been interested in sustainability that have gotten LEED certified buildings on them. But the gardens themselves are typically not very sustainable. This is a way for us to change and rate that. Even streetscapes and plazas. We've been talking to folks in Portland who are involved in our planning process, and they're looking at this as a planning tool where you can think about an entire city as a site and start thinking about how do you utilize this so that my city has no net loss of resources. So it really begins to value the green infrastructure that's part of that space. I'm just going to run through very briefly some of the current areas of research, give you some ideas of where we're going and what we're thinking about. The 5 areas that we're currently researching are hydrology, soils, vegetation, materials, human well-being. Over all of this, we just brought on 3 economists to help us evaluate in terms of economics. We've also brought in 5 new people from the Center for Disease Control, one of which is both a landscape architect, a medical doctor, and a sociologist. Right? One person has 3 degrees, and I was like, wow, this person's perfect for this, right? So we're really excited about the people we've been able to bring in. We just brought on Greg McPherson, who is a forester who's been doing a lot of economic studies of the trees in these landscapes. So we're really starting to build up the part of not just knowing what to do, but also be able to value in terms of human health, in terms of economics, how these things are relating to achieving. So hydrology. The first thing is that we have to recognize the impact that urban systems and development has on our streams and wetlands and those associated aquatic habitats. We have done a really good job in Austin of trying to reduce pollution that's hitting our streams, creeks, and rivers. We have these great ugly big ponds that capture and hold the water, slow it down, and we've really reduced flooding. But what we haven't done is truly sustain these creeks and rivers, because the way that these ponds work is that they capture the flood while the rainfall's falling, and then 48 to 96 hours after that they release that water to the creeks. Now it all comes in one big wash and it washes down the creek, and that's really changed from what it would have done pre-development. Pre-development, you would have had that water fall on the ground, and a bulk of it, at least half, would have been absorbed into that ground, in the shallow groundwater. And while it wouldn't necessarily have fed the aquifer, it would have slowly moved through the ground and eventually come out in springs and stream flows into those creeks. Now, so what we've done is we've changed streams that rely on the slow percolation of water in order to preserve their aquatic habitat and to have year-round water. We've changed them into Waller Creek that only carries water when it's raining. We've robbed them of the water they need to sustain themselves. And as a result, these drier habitats don't do as good a job for us in providing cleaner water and doing the sort of other ecosystem support services that we've come to rely on. So how do we start changing that? Start designing systems that really focus on infiltration and start bringing that water, not just holding it, keeping it from flooding us, but also improving that water quality and getting it into the ground wherever possible. We need to use less water, and we need to use the water we use much more efficiently. So that means we need to start thinking about harvesting gray water and reusing rainwater. Even if it's just for landscape purposes, it seems incredibly silly to flush potable water, potable water. So we've got to get to the point that we're being smarter about the water we use, and we use drinking water to drink and to cook with, but that we can use other types of water that may be not as clean and doesn't require the same level of electricity to get it to us and to get rid of it, and use that water 3 or 4 times as it goes through the process. And again, try to, as much as possible, get that water off of impervious surfaces and into areas where we can get it infiltrated into the ground. Soils. Soils are critical. We have more biological diversity below ground in the world than we have above ground. And yet it's the true last frontier that we haven't really thought about yet. And we don't really understand the relationships between soil microbial communities and the health of the environments. So we need to do more research there, but we need to make sure that at the very least we know that those species that are down there need oxygen just as much as we do. And when we compact the soil, we impact that and the ability for oxygen and water to get down there. And too often what we see when we do a development project is you compact the hell out of the soil around your building, and then if you're lucky, you spread 3 inches of topsoil back on the top of it. More often you spread sandy loam, which in this part of the area we refer to as red death. Real easy to smooth out, so the construction guys like it, but it's not going to grow any plants very well. So you spread that out back on top of it and you say you're done. But in fact, the hard pan layer that's down there that's had all the equipment running over it is like concrete. And you're getting no infiltration. You get no air down to those biological critters that are going to be able to do the breakdown of the nutrients and cycling that you need in order to have a sustainable site. So at the very least, we have to be aware of how we're treating our soils and take steps to positively impact those. Limit soil disturbance. Every time you disturb the soil, even if you're going to reuse it on your own site, you volatilize a significant amount of carbon that's been stored in there, and you actually are contributing to greenhouse gases. Most of us don't realize it or really value it. If we really want to say what has caused the most carbon addition to the atmosphere over the last 150 years, it's not industry, it's not buildings, it's agriculture. Just by tilling the soil, we've released more carbon through agriculture than we have in any other type of activity that humans have done. Now, I'm not against agriculture. I like to eat, right? But we do need to be aware of that and recognize that this is something that as we can move to more perennial crops, as we can find ways to minimize soil disturbance, if we really want to contribute to reduction of greenhouse gases, that's a really important first step. A lot of the chemicals that we use on a site, we are finding out that even though they don't seem to have an adverse effect on water quality, even though they may not have an adverse effect on neighboring plants, we're finding out that they can have a very important adverse effect on soil microbial communities. And again, we have never really thought about that. So an IPM plan, an integrated pest management plan, will reduce the amount of total herbicides and other chemicals you're putting on the ground. Doesn't mean you don't use them, but you want to use them sparingly. And again, you can manage soils, and I don't think I'm going to have time to run through an example here, but there are ways you can manage your soils and the landscapes that are on top of your soils so as to promote greenhouse gas sequestration, both in terms of methane production, minimize methane production, and actually maximize below ground soil carbon storage, which is really your permanent carbon storage and the answer to agricultural production that's been going on. Potential strategies of vegetation. Of course, plants filter pollutants. They take up a lot of the things that we consider pollutants, and they're bad things when we get into aquatic habitats. They can take them up and use them as resources. Even petrochemicals and complex carbon chains that are oftentimes dripped out of cars and other things, those can be taken up and used and broken down and become food for plants if we use them properly and give them that opportunity. We want to think about everything from maintenance plans. Think about where you're putting plants so that you don't have to go back and chop them down later on. Think about, if you guys are thinking about planning in a regional purpose, think about those power lines and not put big trees underneath them so you don't have to go back and cut them down later on. All sorts of things. We just need to be smarter in thinking about what we're doing. And of course, the wildflower center has been a big proponent of also utilizing native plants, or at the very least, regionally appropriate plants. Too often we use plants to do one particular job, not having investigated them far enough. And we find out that while they do that one job, maybe it's erosion control, very, very well, they also eat houses and cars and everything else like kudzu in the southeast. They get out of control and they cause more problems than the problem they were intended to solve. So we need to be thinking about things much more holistically than we have in the past. And we like to think of this, if we just try to err on this, you may not know it from talking with me if you ever get a chance. We try to be humble. It's tough for me. But if we're humble about this, we just try to use the plants that are already there. And there's plenty of great resources that are for us. To give you an example, here in Texas, there are currently about 300 species commercially available, of 300 native species to Texas commercially available. There are over 6,000 plants native to Texas. So I always laugh when I hear about some of these guys going over to China to do a plant collection trip. We haven't even fully investigated the plants that we have here, let alone, there's no reason to go beyond your own borders. If you're in China, that's great, but if you're in Texas, why go over there to look for plants? Go to the Chisos. That's pretty random. Anyway. Materials. So, reuse. I'm a Texan. All right. Reuse, renovate. So, actually, I get corrected. I use the classic reuse, recycle, reduce, reuse, recycle. I've been pointed out by some of the folks I work with at the EPA that the fourth and most critical component of this is rebuy. That means as consumers, we need to be shopping for things that have post-consumer recycled content to them. Otherwise, there is no market for these things. And too often you'll see that we're spending lots of money on recycling, and yet those products aren't actually getting utilized in the marketplace. So rebuy is probably a critical part of this. But we also need to think about not only the products themselves and how stable they are. PVC is a great one in terms of being relatively stable once it's created. But the manufacture process is really pretty catastrophic in terms of emissions. So we need to be thinking more about the entire life cycle costs and life cycle costs and benefits of some of these products. And LEED is a great tool. It's already started doing this for buildings, but a lot of the landscape materials have not yet been evaluated. To give you a great example, we're talking about all the benefits of trees in terms of carbon sequestration, cleaning water, and everything else. But oftentimes, if you're buying that tree, and it's a relatively large one, you stick it in the ground, and it's spent 4 or 5 years in a nursery, and it ended up getting shipped from across the U.S. To your locale, you may have more embodied carbon in that tree than that tree is ever going to sequester in its lifespan. What I mean is that you've invested more in terms of emitting carbon from the equipment to transport it, from the water to grow it, from the chemicals that were put on it. You may have already emitted more carbon than that tree can ever sequester in getting that tree to you. So we really need to be thinking about total life cycle costs as we start thinking about the landscape if we're going to truly achieve some of the things we want to achieve. So there's obvious, getting people to have access to natural systems is going to be a critical one in the future. Both visual access, physical access, and sort of that emotional tie that allows them to get out in there and really feel like there's an outdoors. Austin's been great about getting green infrastructure into the city in the last 25 years. And it is a good model that a lot of other cities are starting to emulate. But so getting access so that someone that does live in a dense urban center within 5-10 minutes can get out to a space where they can go for a several-mile jog or walk or see that green space is really important. All right, so doing okay. Okay, upcoming reports. So we just released our first report in November 2007. It is available for free at sustainablesites.org. And what it basically tells you is sort of the direction we're heading in. We purposely had a lot of holes and gaps. We just had a 45-day comment period that we had it was downloaded over 15,000 times, and we received over 450 substantive comments from organizations around the world. FYI, the 4th most popular place to download it is France, in terms of where it was downloaded, which we thought was really cool. We need to have a field trip to go find out what's going on over in France, because they're doing something interesting, and they think we're doing something. Anyway, but so it's there and available, but we're still going on from there. We're starting to respond to the comments. We're continuing further research, and so our next draft of this is going to come out in the winter of 2008, so later this year, the end of this year, and the final standards and guidelines that would be sort of the guideline for how you would develop a sustainable site will be available by the summer of 2009. Now, what's that mean? We still won't have a rating system. The very next step is to create that rating system. So it's right now we're in this phase, standards and guidelines. The next step is once we know what to do, how do we evaluate that and provide a ranking system and score system that's going to go as part of this, and that'll happen next. We'll also have a pilot phase program where we work with probably 100 to 150 projects across the U.S. to try to follow the guidelines and standards that we set out, and we'll learn a lot from those. And they'll be able to tell us, this worked, this didn't work, this is nuts, there's no way you can do this, or that was actually too easy. You need to set the bar higher. And we'll use that information, develop a reference guide that will help people through this process, and this is a very similar process to what LEED's always used. And then we'll have it available as a rating system. The U.S. Green Building Council has already committed to incorporating sustainable sites into LEED v3, so that this will become part of the U.S. Green Building Council's LEED program. However, it's also going to be part, we're hoping to get part of the National Association of Home Builders program. We're also having conversations with Green Globes. We're not limiting ourselves to any one certification program. and it will always be available for free as it is. We're not going to become a certifying organization, but if you're a park and you just want to follow the guidelines and you don't have enough money to certify or you don't have any desire to certify, you can follow the guidelines and it'll be available for free, and you can use it as a self-assessment tool. So we're very excited about that and what's available to. I have to thank all the organizations that are involved and the folks that provided funds, particularly the Meadows Foundation, the US EPA, and the United States Botanic Garden. And we've also gotten money from TCEQ, Horticultural Research Institute, US Forest Service, and others. So it's been critical to have that kind of broad range support. This is a $2 million project spread out over about 5 years. So getting that support's been really important to us. We've got, at the Wildflower Center, I've got 3 staff that are working on it full time, in addition to part-time from me and other folks at the Wildflower Center, some time from ASLA and their folks too as well. For more information, go to our website. It's all there. It's all downloadable for free. You can see where we are. You can send us emails, send us questions. You can contact me directly at the Wildflower Center. And with that, all of it. Oh, actually, let me do one more thing real quick. In terms of carbon storage, I realize this would probably be really kind of relevant to you guys. I'm going to skip the lecture on where carbon goes. All you need to know is, this is what happens when you animate it. All right, come on, all right. Here's the important part. So what you've got is, if you looked at the net change, there's a lot of back and forth in the environment. And folks have really been focused on the fact that we create a lot of fossil fuels and that goes up into the atmosphere. And that's really important. So that's, we have 5.5 pentagrams going up into the atmosphere on an annual basis. The atmosphere, however, so it's gaining carbon, but you've also got soil has the opportunity, and on an annual basis, it's sequestering a bunch of that. And of course, then we have the oceans that are sequestering even more. But we can't really increase the sequestration that's going on in the oceans, but we can, well, there's been some discussion of that. There's actually a lot of programs that are currently trying that. But we can really enhance this one if we think about it. And that's where we have the most potential for change. Let me show you an example there on how that would work. This is peatland. This is why you don't want to ever see peat, or peat moss or sphagnum moss included in a project you're working on, because it is robbing this carbon storage that's been long-term, below-ground carbon storage, and releasing it up into the atmosphere. But here's another good example. Here are prairies and grasslands in the U.S. When those were converted from prairies into agricultural fields, that's when we volatilized a lot of that carbon and it went up into the atmosphere. But that also means that by restoring those prairies and grasslands, we have a lot of opportunity to start sequestering that carbon and pulling it down out of the atmosphere. And if you think about that, and we also found, great study, found that more diverse prairies sequester greater amounts of carbon than less diverse prairies. So it's great when you start hearing conversations about using switchgrass as a biofuel. But it could be that using a full prairie as your biofuel might be even better. And then we worked with Methuen, which is a landscape architecture planning firm up out of Seattle, to create buildcarbonneutral.org. And this is the first carbon calculator we're aware of that is actually focused not on operational carbon, but on embodied carbon. And embodied carbon is the carbon it took that you emitted in order to construct your building in the first place. And what we wanted to do was, see, the reason this is important is that you can probably get to the point that you have such an efficient building that it is sequestering more carbon than it uses or emits, or at least it's at a net zero. But the construction phase of that is almost always going to have excess carbon. So you've got to make up for that. Our goal was here to see if you could find a way to balance your landscape future sequestration amounts with the building to see if you could actually come up with a net neutral. So here's an example. Take a 40,000 square foot building. We ran the numbers on it, and an estimate of the amount of carbon that's embodied in the creation of that building, not operational, just embodied carbon, is around 240 metric tons. So let's say we add a little 10,000 acre prairie somewhere on the landscape surrounding that, we can sequester about 20 tons of carbon, so we can knock that 240 metric tons down to 220.
10,000?
10,000, no, not acres, sorry, square feet. Thank you. 10,000 square feet. So a little prairie outside the building. Now let's say we had another 10,000 square feet of just shrubbery and sort of general vegetation around there. We can get another 15,000 metric tons. Well, let's say we add another 10,000 square feet of forest, woodland in that area, and that's going to take us down another 15,000 metric tons of carbon. But now let's pull out the big guns. Let's pull out a wetland. And it's going to sequester around 200 metric tons per 10,000 square feet of carbon over time. And so now we're at a negative carbon value. We actually have now sequestered more carbon than it took to build that building. Now, just for giggles, let's add a green roof on the top of it, and now we're at even bigger negative numbers. Now we're at negative 15 tons of carbon. So it is possibly done, but you're never going to get there without considering the site and the landscape. That's it. Thanks. I appreciate it. And of course, I'll be happy to answer any questions you guys have.
Questions, comments?
Oh, just a generic one, that ULI study that you referred to, what study is that?
If you'll send me an email, I got it. It came out last year. I actually have the notes.
I can send it.
Just send me an email. I can get you a copy of the study. But it's actually really done. Again, well done. Five critical parts that I think that need to be focused on. It's a good study to look at. Yes, ma'am.
Question about, with the Walker plan, is there any ideas about incorporating more native grasses and some of the redesign of the landscape, like the arboreal least wall, which is just very kind of impacted right now? And
I can't answer that because I haven't been involved in redesigning any of those systems. The Wildflower Center does work. In addition to doing research like this, we do fee-based consulting off-site, but we haven't done anything yet with the university. Kent and I both sit on the sustainability,